So here we are asked to solve this triangle ZXY, where we have measurement Z, side Y, and side Z. So I'm going to draw this out first, and drawing is kind of I would say one of the trickier parts of this. My angle, I'm going to call this Z. I always like to put my angle in the bottom left. Remember that the letters, if they match, they should be opposites. So my angle Z should be the opposite of letter Z. So that means that Y has to be an adjacent side. So I'll call that 34, and I'll call this 33. So this is that situation here. The way that I drew this, I'm hoping you see, is where we're given a side-side angle, meaning an angle that's not in between the two sides. That's the situation where we don't know how many triangles can be created from the given information. So we have to do a height test to check. So if you notice, I didn't connect these because I don't know if they do, or if they connect once, or if there's two possible ways I could draw this. So I've sketched this out, but I need to do a height test first so that I can check to see how many triangles I need to solve. So for this one here, a height test, it's nice that I have set this up where the angle's in the bottom left, the adjacent side is on the left side, and the opposite side is on the right side, because now my height is vertical, up and down. So to solve this, I can just say sine of 57, because this is a right triangle that I've created, equals the opposite side, which is our height, over the hypotenuse here, which is 34. So to find the height, 34 times sine of 57. And now I'm going to go ahead and plug that into a calculator. 34 times sine of 57. And I get my height of about 28.5. So in this case here, my opposite side is between my height and the adjacent side, which is where we find that there are two possible triangles created. One where we're on this side of the height, and one where it's on this side of the height. Two possible triangles. So a couple things about this. For me, the way that I like to do these problems, I don't need the height anymore. I just needed the height to check to see how many triangles. Then from there, now that I know there are two triangles, I'm actually going to sketch both of them out. They're not going to be perfectly to scale, but I know that I'm going to have the one that's a little bit larger, and then I'm going to have the one that's the little skinny guy, which ends up being like my obtuse triangle here. So I'm going to call this triangle 1. I'm going to call this triangle 2. And I know a couple of things about both of them. I know both of them, this bottom left angle is 57, because that's what was given. I know the adjacent side here is 34 for both of them. And I know the opposite side here is 33 for both of them. Again, you can see triangle 1, like it's not to scale, so it's not a perfect representation of that. But you get the idea. All that information is set in stone. That's what we're given. Now we need to find the other angles on the other side of these triangles to completely solve it. Now to do this, if you notice, I have one set of opposite sides and angles. I'm going to start with triangle 1 here, because in this one here, I'm going to be solving for this acute angle. I'm going to do that first. That's very important and key to understand. So to do this, I'm going to use my law of sine. So I have, sine of the angle that I'm looking for, which I should probably use the correct letter here. When I'm looking back over here, that's going to be y. So sine of angle y over 34 equals sine of 57 over 33. So when I solve this, I multiply both sides by 34. So I get sine of y equals 34 times sine of 57 over 33. And then I want to take the inverse sine of both sides to get y by itself. So in a calculator, I'm plugging in the inverse sine of 34 times sine of 57 divided by 33, which gives me my angle of about 59.778. Do I want to round that? Yeah, let's call it 59.78, just to make it nice and pretty. So that is the angle here. I'm going to erase some of this to kind of go back to my original drawings. So this angle right here is 59.78. Now, here's the hard part, and I don't have the visual ready for you, but there is a visual out there that shows that when I create these two triangles, the angle, the blue angle here of y, is supplementary to this green angle here for angle y. Supplementary meaning that they add to 180. So to find this bottom right angle, I'm just going to take 180 and subtract 59.78. So I know this obtuse angle has to be 120.22. Again, that's rounded. So that's the key to getting this bottom right angle for triangle 2. Now I can just solve the rest of these triangles how I would solve any other triangle. So the first thing that I'm going to do is find the third angles, because that's usually the easiest thing to do. So for triangle 1, 180 minus 57 minus 59.78. That gives me angle here is 63.22. Sorry, the handwriting here is not great. And then for triangle 2, I'm going to do the same thing. 180 minus 120.22 minus 57. Woo! Is that right? Wow, that is a tiny angle. So that angle is 2.78 degrees, which is tiny. But I guess it makes sense because these two side lengths are so close together. So angle here is 2.78. Now the last thing I got to do is find the final side length. So again, I'm going to use law of sines. I'll do it in pink here for this one. So for this one, I'm going to do x over sine of 63.22 equals 33 over sine of 57. So I multiply both sides by sine of 63.22. Plug it into my calculator, 33 times sine of 63.22 divided by sine of 57. And I get my value of about 35.13. So triangle 1 is now solved. I have every angle and every side length. And for this one here, I'm doing the same process. I now need to use the other angles though, right? So I'm going to say x over sine of 2.78. This is going to be a very small value. Equals 33 over sine of 57. So I multiply both sides by sine 2.78. 33 times sine of 2.78 divided by sine of 57. And I get my side length of, again, I knew it was going to be small, but 0.17 for my last side length. So I know it's not pretty, people, with my handwriting here, but both triangles now solved, which is how we solve something like a side-side angle that can create two separate triangles.